Hello, everyone. My name is Heiko Hotz. I'm from Google. I'm a generative AI specialist at Google. Before that, I was 3.5 years with AWS, also as a generative AI specialist. And what does that mean? I work basically with customers, with organizations who want to use generative AI on our platform. So be it like fine-tuning large language models, hosting them, maybe even training from scratch. Bloomberg did that on AWS SageMaker last year with the Bloomberg GPT. So I work with these organizations basically to be successful with their generative AI workloads on our platform. But tonight I want to talk about something completely different, a little side project I'm working on, and that has to do with what I see, or what I could see LLMs being used in the future. And that is basically as the CPU, as the computing processing unit of a large language model operating system. So an LLM OS. And the reason I want to talk about this, and the reason why I'm working on this, is that the creators of the Falcon models, if you remember maybe the Falcon models, they were created in summer last year. Back when they came out, they were the top performing open source large language models. It was right before Llama 2 then stole that spot. But the Falcon 40B models were the first models, or the Falcon 40B model in particular was the first model that I could use back in my days at AWS and demo with customers what is possible with open source large language models. Before that, I always had to use proprietary models like AI21 or Anthropic. For some reason, we didn't use OpenAI's proprietary models at AWS. I'll let you figure out why, but Falcon 40B was the first time I could use an open source model and do something like talk to your document chatbot, upload a PDF file, and just very similar what we saw in the demo here. That was possible with the Falcon models. And then with subsequent models, it became always better. But Falcon was, for me, like that turning point. And the creators of the Falcon model, the Technology Innovation Institute from the UAE, they had a call for proposals for use cases with their Falcon 40B model in July. And I submitted an idea and it was selected. So I'm working now with the Technology Innovation Institute and also together with Weights and Biases on a project called Falcon OS, an open source LLM operating system. The first blog post I published, I think in December last year. It's going to be an ongoing project as I find time to work on it. But basically the idea of it is having a large language model as I said earlier, as the brain of an operating system, or a system that can do many different things. And that could be like obviously reading and generating text, but also browsing the internet, accessing files, accessing video and audio, accessing tools like a calculator, APIs from Wolfram Alpha, and so on. And my girlfriend recently asked me, like, well, can you explain that to me? You know, like she's not very technical. Can you explain to me what that would look like in the real world? And my attempt to explain it to her was like, if you think about your phone, usually most of the apps that you have on your phone are crutches for you to get something accomplished. Could be like ordering food or getting an Uber from A to B. Who won the game last night, ordering a pizza. And the idea of an LLM operating system is very much like you have with the board computer on Star Trek, you know, Enterprise. You just speak to it in a natural language, and because it's a large language model, it will understand your request and it will reason what kind of tools it will need to fulfill your request and act on it as well. So that's the idea here. And the slide or the diagram was actually stolen. I stole that from, borrowed that from Andrej Karpathy, who is one of the thought leaders in the LLM space. And I want to basically be Falcon 40B, that open source large language model, to be that LLM in the middle. And there are certain challenges when you are trying to use an open source large language model as the brain of such an operating system. And tonight I want to tell you a little bit about what are those challenges, how does it compare with if we were to use a GPT-4 as the LLM in the middle, and what I plan to do to overcome these challenges in order to get to a similar performance. The framework that I'm going to be using in order to have a large language model reason and act was actually developed already in 2022, in October 2022, by researchers from Princeton and Google. And the idea there is that you can use language models by prompting them in a specific way so that they can reason and act on certain requests. That all sounds a bit abstract. I'm going to also show a demo what that's going to look like. So live demos are always fun. Let's see. Right. So what I'm going to do here is I have a specific query. And the query is how far is Kirkwall from Plymouth? And first of all, what I want to do is just post that question plain, without any React framework around it to GPT-4, see what it answers. Then we're going to apply the React framework in order to make GPT-4 reason and act and see how that improves the performance of the response. And then we're going to do the same with Falcon 40B and see what is the gap between Falcon 40B as an open source model and GPT-4 as a closed source model. And how can we go about overcoming this skill gap in reasoning and acting? So let's start with loading some stuff. So this is the query. And now this cell here, I'm just going to send that query directly to GPT-4. And it's going to take a few seconds. Yeah, so that's why, hosting on inference servers locally. Yes, exactly. Basically, we get a long-winded reply back. And this comes from the internal knowledge of the LLM. This is what it has learned, during pre-training. It comes back with a reasonable response. The straight line distance is approximately 530 miles, but sometimes that's just not good enough. We're going to see it's off by more than 10%. And if you want a precise answer to this question, that's just not good enough, let alone that the answer is very long-winded. So now we're going to basically enforce the React framework onto GPT-4. And what that really means is we're going to tell it, here are some tools that you can use in order to answer a question. If a question comes in from the user, first reason which tool you would want to use, and then also use that tool in order to reply to the user. So we're going to give it, in this case, we're going to give it two tools. One is basically a search on the internet, and the other one is a Wolfram Alpha API. And you can give it some descriptions so that the language model can decide which tool is it actually that I want to use if I'm going to be asked about a distance between two cities. So we, I described the search as like useful for when you need to answer questions about current events. And Wolfram Alpha, I told it it's useful for you when you need to answer questions about math, science, or geography. So I'm going to run the exact same query again, but now on top, I have this React agent, which basically tells the large language model what I just said, right? Reason which tool to use and use that tool right away. So it starts reasoning to calculate the distance between two cities. I can use a geographical tool. I'm going to use of the two tools that I have available. I'm going to use Wolfram Alpha. I'm going to use it in this way. I'm going to type into Wolfram Alpha distance from Kirkwall to Plymouth. The response that comes back from the API is 494.7 miles. And now in a typical RAG fashion, we can take this response from the API, put it into the context that we're going to send to the LLM together with the user query. And the response is now Kirkwall is approximately 594.7 miles away from Plymouth. So we have now seen that this React framework gives the LLM a much better chance of success to answer certain user queries. The secret behind it, I already alluded to that, is just a prompt. It's prompt engineering. Instead of giving the question direct to the large language model, we give it this long prompt with instructions, with a format that it should follow. And just by doing that, we enforce reasoning and action onto the large language model. So this is all great. It works really well, but it's with GPT-4, and I really want to make that happen with an open source LLM. So let's look what happens if we do the exact same thing with Falcon 40B. So I have Falcon 40B deployed on a Amazon SageMaker endpoint. The reason why I'm using Amazon and not Google is because TII, who approved and sponsors this project, gave me, ironically, AWS credits, although I just switched from AWS to Google, but that really doesn't matter where I host the model. All you need to know is there is a Falcon 40B model in the background. We have the exact same query. We have the exact same tools. And you will see that actually with the reasoning, it's doing okay. It identifies the right tool. The right action to do is to use the Wolfram Alpha API, but it uses the API slightly awkwardly. It didn't say like GPT-4 did. It didn't say like, type this into the Wolfram Alpha API distance from Kirkwall to Plymouth. It just said Kirkwall on Plymouth. And the response, whatever came back from Wolfram Alpha, was just not helpful because the input into the API was not helpful to begin with. And then, it does a few more runs, but in the end, it will just error out. And that is the challenge that I'm seeing with open source LLMs. Now, to admit, it's been a while since Falcon 40p came out. Again, that was in June 2023. So much has happened in the meantime. It might be that Mixtral, for example, will do much, much better on this. But again, this is like a little side project for me. And going back to the slides, basically what I want to get out of this is to understand better what needs to be done in general in order to make these large language models to be the the brain of an operating system. And that is regardless. You will have challenges with any open source LLM, be it Falcon, be it Mixtral, and probably even with closed source models. But again, with closed models, you don't have influence over how you can train or fine tune them, at least not to the extent that you would need in order to achieve this goal. Obviously, we have some levers, inference parameters, temperature, top K, top P, and so on. We could also tinker with the prompt template. But my hypothesis is, in order to get the best results for this React framework, is to fine tune these models. And once you start thinking about that, like, well, how do we do that, right? We need to create a training data set in order to fine tune. What I mean by fine tuning is really just giving it lots and lots of examples and learn from that. It could be like the data set looks like exactly like the question we saw, and we tell it, this is, you know, the reasoning that you should be doing, and this is how you should call that API. And we show it over and over, many, many different examples, hundreds or maybe even thousands. But how, first of all, do we create these examples to fine tune the model? We could crowdsource, we could use a different LLM to actually create these examples. What's the best format for the training data set? How then do you fine tune? Do you use LoRa, QLoRa? How many adapters? Should I have one adapter per API that I'm training the model on? Should I have, where do I store all these adapters? Can I hot swap them depending on which user query comes in? So many questions. I am at the very beginning of this project. Next steps for me are like, what are the first set of tools I want to work with? Internet search and Wolfram API are probably very good candidates. I might also want to look at a weather API or a, I don't know yet what besides web search and Wolfram Alpha. And then I also need to identify and quantify the gaps that arise when I swap out GPT-4 for Falcon 40B in order to see where does the model perform already well. We've seen that Falcon, for example, already reasoned that it should use the right tool, but it was just not very good at using that tool. So might be that for different queries, it can't even reason which tool to use. So all of these things need to be experimented with and found out and basically quantified. And then, so basically that's the next steps that I'm going to be working on. Just to summarize, Falcon, a large language model, I want to use that as the core of a large language model operating system. The most promising framework that I'm seeing right now is the React framework in order to do that. Looks like Falcon is not quite there yet, but maybe we can get it there through prompt engineering, experimentation, and fine-tuning. That's it. If you want to follow this project, you can follow me on LinkedIn and on Medium. And any questions? All right.
We'll start at the back because the microphone is there, but we'll work our way forward.
Have you read the Zuta paper on model ensembles?
Say again, which paper?
The Zuta paper.
Zuta?
Z-O-O-T-E-R. It's a silly name.
No, I've not seen that.
It's only in our company. We've got an equally silly name for it. But the basic idea is that you have multiple small models, each of which is fine-tuned to do a very specific task, so that you can stop worrying about catastrophic forgetting and the like. But the idea would be that you have a router model at the front, a 7B, and the router model is trained on instruction pairs to figure out which of a set of models to pass a given request to. So you ask the distance between two places. That looks like a Wolfram question. It passes the request to the Wolfram specialized model, which knows how to make that kind of tool request, which then makes the correct request. So you're basically tying together as an ensemble multiple 7 billion, 13 billion parameter models. And just going back to the previous presentation, I don't think we should be waiting for an open source competitor for GPT-4. We can achieve what GPT-4 does with ensembles. And that's the way we should be trying to achieve this. Sorry, it wasn't a question, but do read the Zuta paper. It's good.
All right, thank you.
My question stems from the React framework, because if it's not the case for RAGs, for example, where we need to be sure that what the system is hallucinating is correct, or it's not the general case for at the moment users are using LLMs, they know that they're hallucinating answers. They know they don't need to take these answers very seriously. And so we don't care much about the explainability. But if we want to have a chain of reasoning, and we want the system to say, I need a geographical tool to calculate the distance between two cities, that affirmation about you need a geographical tool, where does that come from? Is there any explainability? That I remember it was something in the research field that was quite in vogue. It was taken very much into consideration, understanding how generative models, for example, stable diffusion models like algorithms like that. It was important to understand why certain decisions were taken, so the explainability of the algorithm. Is it that something that is taken into consideration, for example, in your use case or in the LLM field at the moment?
Yeah, so basically you're asking is, if the model chooses to use a geographical tool, why actually did it choose that? Yeah, to be honest, I haven't seen a lot of promising research on that one. It's not something I'm particularly concerned with in the scope of this project. To me, like, I'm the first one to admit the whole LLM prompting that we are doing right now is a bit like alchemy to me. It's like, you know, we're trying different things. We're seeing what works, what doesn't work. We can't really say why. Short answer, no, I'm not looking into that in the scope of this project, and in a wider scope, I haven't seen many good ways of explaining why an LLM actually answers or responds the way it does now. I think there's a question over there.
Thank you very much. I wanted to ask a question regarding Rabbit One. They launched this large action model, right, with the Rabbit device. And I feel like it's kind of similar to what you're trying to build. So a friend of mine was experimenting with integrating other platforms into an LLM agent, right? Like using ChatGPT wrapper. So what they do is that they pick functions, they build their own UI, they pick functions from your chat and use it to connect to their platform, to the platform. So what it does is that, for example, it can send an email and say, hey, send Sam an email, tell him I'll be 10 minutes late for a meeting. So it picks the word send and email, then it connects to you already authenticate your Gmail with it in the backend, then it sends you an email automatically. So he was thinking about different use cases like Uber, like other consumer apps, and it's similar to what the Rabbit guys kind of like built. So talking about building an operating system, an OS, like, are you thinking outside of say the developer space into consumer space? Is there something similar to what you're trying to build? Yeah.
Well, to be honest, I don't have like an end product or a service in mind that comes out of this. Like, I'm basically just tinkering. This is, as I said, like a side project that I'm working on. I have no end goal, but all I want to do is learn basically how to set up a system like that, and you know, write about it, and hopefully provide some lessons that I can pass on to someone who wants to do something similar. But in the end, I have no end goal or vision in mind for that, in terms of like whether this should be, you know, what kind of product or service this should be.
Thank you.
Hey, yes, I've just got a quick question. So imagine you've like built version 1 and you've got like Wolfram Alpha integrated and like Google, and it works pretty well. How would you sort of see integrating like another like service or like another kind of module into the LLM? Would you have to sort of retrain or LLM with like some new prompts? Like what's the kind of scalability of like this?
Yeah, so that's
Falcon
something
OS?
I really would love to experiment with the LoRa adapters on. So basically what you're doing with LoRa fine tuning is you keep the base model, the 40 billion model, unchanged, and you're basically training something else, something much, much smaller. It's called an adapter on top of this large language model. And that will change the behavior of the basic LLM as if you had trained it itself. But because you're training something much, much smaller, it is much more scalable, cheaper, faster, and so on. And that's something I'm really interested in trying out, because a lot of organizations I work with professionally in my capacity at Google are asking me the same questions, and I just don't have a really good answer to it. It's like, you know, should we train, how many LoRa adapters should we train? Should we hot swap them? Can we do that? Can we layer 2 LoRa adapters on top of each other? How does that work? These are all open questions that, you know, I hope I will have an answer to sometime in the future.
Yeah, just following on from the point earlier about the Zuta paper, are you considering sort of agents and agent orchestration for this? Because in addition to that paper, there's quite a good one produced in Nature called Co-Scientist, I think at Carnegie Mellon, where they were able to build a group of agents, and they had sort of an orchestrating agent, which was then fielding out activities to the sub-agents for formulating chemical formula, running code, then executing that in a chemistry engineering environment as well. So yeah, is that kind of something you're considering?
Yeah, so basically when you use the React framework, you're actually making your LLM act as an agent. The abstract way of thinking of an agent, at least to my understanding, is you give it some sort of input, and it needs to, based on that input and the environment, basically take some decisions. And basically what I'm doing is I'm, you know, misusing my large language model as an agent. I'm basically making it the agent, and that doesn't mean necessarily that it needs to be the only agent. So if I understood the premise of that paper, of that SUSE paper correctly, it could be that there is many different, well, first of all, agents, but even different LLMs working as these agents. But yeah, so basically, short answer is yes. The core concept of the whole idea of an LLM OS is based on agents.
Have you tried using inference harnessing to shape the tool use?
What exactly is inference harnessing?
Well, something you can very easily do with local models, and not quite easy with something like something hosted elsewhere. When you have an access to all possible tokens, all possible next tokens, you just restrict the syntax of what it can produce, or if you add some monitors looking for specific keywords or specific syntax, you can inject tokens to to kick it off the wrong track, to suggest something. And it worked particularly well with small open source models. So I guess something like this is possible with Falcon as well.
Yeah, probably.
To shape the tool use.
Yeah, because the nice thing about open source models is you have complete control over like the input and the output. You have access to the logic biases. So yeah, I'm right now at the stage where I need to quantify and identify how big is the gap. So I'm not even yet in solution mode, but once I get there, that is definitely something I should have a look at. Yeah.
Me? My question, by the way, is very interesting idea. Thank you for sharing that. When you say Falcon OS, like, are you envisioning it to be an OS by itself, or it will be operating an existing OS, like, but it will be just an interface between human and the operating system?
Yeah, so the latter. So basically coming back to that idea of like, you have your phone or a rapid R1 device, doesn't really matter, but basically you have or maybe to formulate it even simpler, you just have a smarter Siri or a smarter Alexa on your phone, right? It's like, that's the whole idea. A Siri where I say like, order me an Uber back home or order me a pizza, doesn't just say something like, sorry, I can't help you with that.
Mm-hmm.
So basically integrated into, again, I'm not working on a product or a service, but the ideological idea behind it would be integrated within a operating system. It would basically be your smarter Siri within that operating system.
I have a follow-up statement and a question.
Sure.
So that will be a operating system operator rather than operating system, I guess, maybe.
Fair enough.
Also, let's say you want to do it on Linux. Would I assume that the data sets like that you kind of need to fine tune the Falcon on would be like defining a task and like the terminal outputs, like the steps that actual human or the user took to achieve the desired result. But I don't have the knowledge to actually how to collect that data.
Yeah, so that's basically what I'm envisioning right now, because it's going to be one of my first next steps is like creating a data set. And the most simple idea I could come up with is like, I'm going to have 100 in like samples of like, this is what the user said, this is the action I want you to take, and this is going to be the action input I want you to take, and fine tune it on that and see, whether that already helps.
Yeah, so I was going to say earlier that OpenAI has a feature called function calling, and if we were able to know how that feature was built, then we'll probably be able to figure it out. But people spoke about this, sorry, what do you call it, Zoot paper or something?
Mm-hmm.
Yeah, they mentioned it, and I figured that that's probably the way it was probably built, because I was experimenting with the agents or the LLM as an agent with tools. And I realized that after using about 4 tools, it breaks down. It starts making errors, maybe sending the questions to choosing other tools that are not meant to be chosen. So I started basically using few short prompt engineering. Basically, if you see this kind of question, use this tool. If you see this kind of question, use this tool, right? But how many of the examples will you be able to give? It's probably not possible, because at the end of the day, if you want a Falcon OS, you probably want an OS that can pick out of maybe 2,000 tools, 5 million tools, or whatever, right? So at the end of the day, I think it just actually makes sense that, okay, you probably have to build an ensemble of models and train each smaller models on to be specific, to be professionals on.
Could be, but could also be that each adapter, again, these adapters are very small, change the model's behavior, that adapter training on all of the, all the different adapters on the same model achieve a similar kind of behavior, rather than having, a 7 billion model that is specialized for Wolfram Alpha. I could have a 10 megabyte adapter that is specialized on Wolfram Alpha. So again, I don't know yet, but I think LoRa and its adapter approach is quite promising. All right, thank you so much. It was a pleasure to be here.